Welcome everyone, and thank you for joining us today for this vWAN Games webinar. For today, I will kick us off. My name is David O'Keefe. I'll give us a little bit of background of why we're here today, cover some introductions. I'll turn it over to Nahali and Cynthia to do a review of how the logistics of today's session will work, and then we will jump right into it with our panel presenters. Welcome to the final series of our ISV webinar series, where we've explored NVA solutions from Checkpoint, Palo Alto, Cisco, Fortinet, VMware Broadcom. Again, my name is David O'Keefe, and I'm thrilled to kick off our session today. We know that many organizations deploy NVA solutions from our ISV partners. However, we've recognized a gap that exists for these partners and customers understanding how to integrate these solutions into Azure vWAN. We've designed this series in our larger Art of the Possible series to bridge that gap. The Art of the Possible series is about exploring the boundaries of what can be achieved. It's about pushing the envelope and discovering new ways to leverage technologies and to solve complex problems. This theme is central to our mission of empowering our partners and customers to envision and realize the full potential of their technology investments. Throughout this series, we've showcased how you can harness the power of Azure vWAN to create robust, scalable, and network solutions. We've demonstrated how native Microsoft technologies combined with the expertise and solutions from our ISV partners can help you achieve your business outcomes. Along the way, we've created reusable and layered architectures to help you plan, visualize, and document the art of the possible. We started this series with a deep dive to explore the scenarios we plan to cover in the series. We followed it with a kickoff session with one-to-ones with each of our partners to explore their individual solutions and how they integrate with Azure. If you missed any of those sessions designed to inspire and equip you with the knowledge you need to replicate these in your own environment, you can find the link to the previous recordings in Nahali and Cynthia's LinkedIn posts. Today's final session in this ISV series is the culmination of all of those efforts. It'll be a fun and interactive session where we're going to recap what we've covered with our partners. Thank you again for joining us. I also want to take a moment to thank our partners Checkpoint, Palo Alto, Cisco, Fortinet, and VMware Broadcom for their willingness to co-deliver the sessions in this series. It wasn't a small commitment, and we appreciate their time and engagement on delivering this high quality content. I also want to thank our presenters. Our presenters have invested countless hours creating this reusable content. They've done such a phenomenal job asking questions of our ISV partners and driving clarity on key integrations. Again, thank you. Sessions like this wouldn't be possible without you. With the background and thank yous out of the way, I want to quickly cover some of our session logistics before we get started. First, we've disabled the raised hand feature for today. Instead, we want to make the session interactive through polls. We're going to ask questions all throughout the session using the poll feature. We won't collect names and your answers will be completely anonymous. Some questions will have a single answer, some will have multiple choice. Additionally, we'll have questions that will have multiple parts. We'll give you about 20 seconds for each question for you to provide your answers. Following each question, the presenter will share the correct answer along with a brief explanation of why that was the correct answer. In just a minute, Nahali will provide a sample of what you can expect. At the end of our session today, Nahali and Cynthia will share the recording via a LinkedIn post. If you want to review the past sessions, you can check out the link to those sessions in the LinkedIn post you used to register for the session today. With that out of the way, let's have some fun and let the vWAN games begin. Over to you, Nahali.
Thank you, David. Let me share my screen and my camera. Can everyone see my screen?
Yes.
Okay. Thank you again, David. and welcome everyone. Great perspective and vision on the ISV series, and I appreciate your leadership, David, on the Art of the Possible series. I will begin with a large shout out to Cynthia. Cynthia ran this session internally for our teams with great success, and we are making it now available to everyone. So thank you, Cynthia, for your thought leadership on this. I love the networking energy on this presenter and partner panel, and I see a lot of familiar faces in the audience from the broader networking industry. So thank you everyone for joining us. And with that, let's have some fun. What you see on my screen is a hybrid multi-region cloud architecture based on vWAN. What you see is two vHUBs, vHub1 and vHub2, an express route connected branch in each of the region. And you would see two spokes, one in region 1 and in region 2. All right, this is the design that we will use as a foundation to most of our scenarios and questions. Now let's look at the legend for today. And you will see that the legend is that when you see this icon, it is the vHub router. Daniele is going to go into the details of the vHub router as well. When you see this icon, that means routing intent is turned on. The questions will have a different color, and the answer almost always will be in green. All right, each of the presenters will present a scenario, and we will use the layers in Draw.io. If you're following along with me, this would look familiar to you. We'll use layers to ask the questions. All right, and all of these architectures are reusable and downloadable from the GitHub repo link in the post. So with that, Cynthia, would you like to add anything to the overall vision for this session?
Yes, thank you, Nirali, and thank you to all the partners that have supported us and the previous sessions we had in this series. So today it's the closing session, and so just to explain what the concept of the webinar. So we've called it the vWAN Games. It will be 9 or 10 scenarios that we will present with multiple questions for most of the scenarios. To give you an idea of what the quiz will look like, we've prepared a sample poll that I will launch shortly. The poll will appear on your screen, and for our example, there will be 2 questions in that poll. Your answers to these 2 questions won't be recorded until you've gone all the way through the end of the poll. Let me launch it so you can look how it looks like. And also you can start answering. So the system allows you to change the answer as long as you haven't submitted them. But well, if you just follow along, we will take the time needed for each question, and you should be fine to both follow the question and answer while we move through the scenario. And as David already mentioned it, all answers are anonymous, so we won't share names. And there won't be a timer either, because the objective is, well, for you to learn and have fun without being too stressed. And I think that's it for the logistics. And yeah, hope you will have fun with vWAN questions.
Thank you, Cynthia. And I'm going to go ahead and submit. And I just wanted to call out this right here that you can navigate if it's a if there are multiple questions, you can navigate using these arrows. So with that, I'm going to go ahead and submit. And we can see the results.
Let me know when I should close the poll.
Yeah, looks like people are answering. We'll give it a few seconds. You guys can see my screen with the results as well, right, Cynthia?
Yes.
Awesome. Yep. So looks good. Yeah, I think we're ready, Cynthia.
Yeah, let me close the poll. All right. Okay. So the poll, well, the example poll has now been closed, and I think we can go ahead and start with probably the first scenario.
Awesome. Thanks, Cynthia. So with that, I'm going to introduce our first presenter. Our first presenter is Daniele, our esteemed colleague Daniele, with our first question. And for those of you who don't know Daniele, he runs an amazing blog as well. So we'll share the link to his blogs as well. So with that, welcome, Daniele. And you have the question on data path.
Yeah, thank you. Thank you, Nihalia, and thank you, Cynthia. I hope you can hear me, okay?
Yes.
So, okay. So according to this scenario that we see on the screen, the first question is about if we have this spoke 1 VNet and spoke 2 VNet traffic, do we have the virtual hub router in hub 1 in the data path for this? So this is the main question. So we have 2 virtual hubs. We have 2 spokes for each hub. We want to know if whenever we want to move traffic from VNet 1 linked to hub 1 to VNet 2 linked to hub 2, we do have, linked to the same vHub, we have the virtual hub router in the data path.
I think you can move forward with scenario.
Yeah, I see. Okay, I see 0 responses.
Yes, because
yeah.
we will see the responses once we end all the questions for that
the
scenario.
end of all the questions. Okay, so basically the answer is yes. Okay, we have the virtual hub router in the middle of the data path for this scenario. Why? Okay, you can imagine at the virtual hub router as the core of the routing inside the virtual WAN hub. Right. So when we are dealing with standard hub and spoke topologies, of course, we all know that routing is not transitive between spokes interconnected to the same hub. We need a virtual appliance mediating the traffic between these two. The job of the virtual hub router inside virtual WAN is very similar to what a virtual appliance does in a standard hub and spoke scenario, right? Actually, the virtual hub router does much more, since it's the core of routing programming for the entire virtual hub and the VMs attached to the virtual WAN ecosystem. But one of the goals of the virtual hub router is mediating the transitivity between the spokes interconnected to the same hub. Okay, so the answer for this use case is yes. Okay, we can move to the next question. Okay, again, considering spoke 1 VNet, okay, and considering branch 1, which is a branch connected via express route to our hub 1, is the virtual hub router in hub 1 within the data path of this connection link? Let's go with the answers. Oh, we already have the answer there. Okay, maybe too fast, but it's okay. So the answer is no, okay, in this case. Why no? The answer is no, because when a spoke is directly connected to a virtual hub via VNet peering, behind the scene we have a VNet peering, even if it's called VNet connection in the context of virtual WAN. We do have all the routes that are learned from the branches that could be including VPN branches, express route branches, or connectivity NVA branches installed as direct next stop from the point of view of the VMs that are deployed inside the spokes that are directly connected inside our hub, right? So in this specific use case, we do not need to have the virtual hub router in the data path for interconnecting a VM running in our spokes. to a branch that is here connected to the local hub that we are considering, okay? I think we can go with the next one. Maybe let's wait a bit before the next answer. So in this question, we are considering traffic between spoke 1 that is linked to virtual hub 1 and branch 2 that is connected via express route to hub 2, okay? The question is which virtual hub routers are in hub 1 in the data path? So do we have any virtual hub router that is in the data path in this scenario? We have the options virtual hub 1 only, virtual hub 2 only, or both virtual hub 1 and virtual hub 2. Okay, let's take some seconds for thinking about that. And maybe we can go with the answer. So the answer is virtual hub 1 only, okay? Again, why that? So from the point of view of a VM running in the context of vHub1, there is no direct next stop for a branch that is directly attached to vHub2, right? So our VM running in spoke 1 must have a locally exposed next stop for reaching branch 2. This locally exposed next stop is the virtual hub router of vHub1, okay? But virtual hub router 1, being directly peered with hub 2 and with its branches, has a valid next stop available for reaching branch 2. And these available next stop will be the MSC routers linked to express route circuit number 2. Okay, so in this very specific case, we do have one single virtual hub router in the middle of the data path when interconnecting the two. Okay, we can go with next. Okay, this is a very interesting one. So often we do have we do have the necessity to have Azure native services in different regions being able to speak with each other, right? This is a very common scenario, and this is where Virtual WAN is also an added value. So in this question, we have spoke 1 VNet, traffic between the spoke 1 VNet that is connected to hub 1 and spoke 4 VNet, and spoke 4 is connected to hub 2, okay? The question is, which virtual hub router are in the data path for this kind of communication? Again, virtual hub 1 only, virtual hub 2 only, or both virtual hub 1 and virtual hub 2. And again, a few seconds for thinking about that. Let's go with the answer. Okay, this case is different, right, compared with the previous question. The answer is both virtual hub 1 and virtual hub 2 virtual hub routers. Okay, why that? Again, as we said for the previous scenario, we don't have, from the point of view of spoke 1, a direct next stop for reaching spoke 4, which is in another region connected to another hub. So we will use the virtual hub router of hub 1 as next stop. But at the same time, also virtual hub router 1 does not have any direct valid next stop for spoke number 4 that is connected to the other hub. So it needs to point to an element, to a sort of intermediate bridge, which can interconnect the link with the spoke 4. Okay, this further intermediate bridge is virtual hub 2 router. So in this very specific case, we will have both the virtual hub routers in the middle of the data path, okay? Can go ahead. Okay, this is a very special one. Okay, so we have another branch connected to our hub one. This is a VPN connected branch. So we have on one side, branch one connected via express route. On the other side, we have an IPsec connected branch. I think it's branch 3, right? So yes, connected via site-to-site VPN. What we want to enable is branch-to-branch connectivity. Okay, Virtual WAN is very good for doing that, both in the, let's say, secured and non-secured hub use cases. This is non-secured hub. Again, the question here is if we want to have traffic flowing from branch 1, which is connected via express route, and branch 3, which is connected via VPN through the virtual WAN hub 1 that we have in place, would the virtual hub router of hub 1 be in the data path for this use case? Answer yes or no. Also, we do see in the picture the toggle that we can use in order to enable the branch-to-branch communication within the properties of the virtual hub. Typically, it's always enabled for virtual WAN unless very specific conditions. We can go with the answer.
Yeah.
Yeah, the answer is no. Okay. Considering what I explained before regarding next stops, local next stops, I think it's easy to understand that when we have two branches terminating inside the context of the same virtual hub, the two gateways have visibility of each other, right? So any gateway can be next stop for the other one. So there is no need for this very specific case of one gateway being forwarding traffic to the local virtual hub router. So again, in this very specific case, the connection will be shortcutted directly from one gateway to the other. So the answer is no, okay? Despite the arrow looks like the traffic is transiting through the virtual hub router, we do not have virtual hub router in the middle for this scenario. We can go next. Okay, here another, let's say, similar use case. Okay, this time we have, again, two branches connected to our virtual hub 1. Branch 1, which is connected via express route. AVS stands for Azure VMware Services, connected as well via express route to our virtual hub because we want to provide AVS environment access to both Azure native services and also services and workloads running on-prem. So the question here is whenever we have traffic from branch 1 to AVS, will be our virtual hub router in the data path for this specific use case? Answer yes or no. And I think we can find out the answer for this.
Yeah, I'm going to hide the question so we could see the answer.
Okay, the answer is no. Okay, why the answer is no? The answer is no, because whenever we talk about two branches connected to the same express route gateway, okay, and this is the same for both standard hub and spoke scenarios and virtual WAN. in Azure, we do not natively provide any sort of transitivity between these two branches. So the traffic cannot be hairpinned to the ExpressRoute gateway between two branches connected over ExpressRoute in order from A to be able to reach B. Okay, this is natively not possible. Whenever we want to make sure that traffic from an ExpressRoute connected branch can successfully reach a destination, another destination or branch that is connected as well via ExpressRoute, we need to implement this technology called ExpressRoute Global Reach. Okay, the Global Reach technology is basically nothing more than an horizontal link. We could see it as an horizontal link between two different ExpressRoute circuits. Okay, branch 1 comes with its own circuit, AVS comes with its own circuit. We cannot transit through the virtual hub natively. Okay, so we enable global reach between the two. Whenever we enable global reach between the two, one important thing to remark is that we are completely bypassing the hub. So our traffic is not transiting through any gateway inside the hub. Okay. Another option to have the traffic transiting through the hub, and that is possible only with, basically almost only with virtual WAN, is to have to enable the so-called routing intent plus ExpressRoute to ExpressRoute scenario. That is, I think, what is, Nihali, correct me if I'm wrong, is what we are already showing here in the picture with the firewall icons directly there, right? So
that's right.
Yeah, exactly. If we convert these virtual hubs into secure hubs and we install a security solution in these virtual hubs, and if we enable routing intent, we have the possibility to enable via special call to support a feature called ER to ER transit. When we enable this special feature, we create the transitivity between branches connected via ExpressRoute to our hub. So branch 1 will be able to talk with AVS, okay, both connected via ExpressRoute, passing through the hub and through the firewall, which is sitting inside the hub. These are the two options that we have in order to put in communication two branches connected via ExpressRoute.
And for that ER to ER transit, we do need to open a support case,
Yes.
right, Daniele, for that one?
That's correct. The routing intent feature can be enabled manually by customer, okay? But the special transitivity feature ER to ER needs a support case to be raised to Azure support team. And as soon as you provide the details of your hub, they will enable the transitivity for you with some drawbacks, but that's other stories. And I don't know if we have any other questions for this data path.
No, I think that's it.
I think it's
for you, Daniele. Cynthia,
okay.
How is the poll looking?
Yeah, let me close the poll. I think we had quite some questions. 1 minute. So seems like we have, so I don't know if we want to go questions by questions, but well, overall, thank you, Daniele, for presenting the different use cases. It's interesting, of course, to know how the traffic flows are happening in virtual WAN, but it's important to understand the flows not only like for the technical curiosity, but also to understand the limit associated to the different components of the virtual WAN, like the virtual hub router has some throughput limit associated to it, but as we've seen, for example, from a spoke to a local branch, we don't use that vHUB router. And another benefit of understanding the traffic flows is that it gives a good understanding of how the virtual WAN pricing works as well, because we have the different components that can be charged depending on whether or not the traffic is going through them or not.
Yes, Cynthia, you're talking about the data processed fees that are applied by the virtual hub itself, right? That is always
Yes.
a question mark in mind of customers, because they never know exactly when this process data has to be calculated and when not, right? So this is why it's important to have clear in mind when the virtual hub router is in the middle and when not, because for all the scenarios where traffic is not hitting the vHub router in the data path, we don't have that kind of invoice from the billing side, right? So that's good to be known.
And when looking at the result, for example, the traffic from the spoke 1 VNet to the branch 2 ER about which vHub is in the data path. For example, we have like mixed answers on the different possibilities. So yeah, it's a good reminder of how it works.
Yep. So thank you.
Awesome. Thanks, Daniele. Great presentation.
Thank you.
So with that, we are ready for our next scenario. So our next scenario is presented by Shruthi. So buckle up, everyone. Shruthi is here. So take it away, Shruthi.
Thank you, Nehali. First scenario that we have here is, you will see in the design, there is an SD-WAN appliance. In the vHub, there is also Azure Firewall. So let's say one of the customer scenarios that I used to get very often is customers, SD-WAN, very common use cases. They have multiple branches connected to it. So can a traffic initiated from spoke go to the for Azure Firewall and then to SD-WAN branches? So is this supported? So Azure Firewall and managed SD-WAN in the same vHub, is it supported or not? I'll pause there.
Yep.
So I think we have an issue with the poll because every time we are pushing a question, it pops up on the screen and hides the scenario, actually. So you can close it, and I think reopen it from the chat, but this is, I think, causing some issues.
Yeah, I need to close it. I see it in the other window. Yeah, thanks for the reminder. I see it in the other window.
Yeah, but I think it's the same for, I mean, this is probably what participants are experiencing, and then I think they're not able to both see the screen and answer the question.
I see. So now is it visible or is it gone?
So, I mean, it's not because we're sharing it, it's every participant will have the pop-up to answer the question, but
locks the screen, yes.
Yeah, it locks the screen, so they are not able to watch the scenario and answer the poll at the same time.
Yeah, maybe we then not launch the poll for now then? Is that because we see the question here? All right, we could do that. I think we'd have to make that decision.
Yes.
Awesome. Yep, so let's roll the answer for this then. Shruthi, good to go?
Yep. So it is supported. So it's a very common use case that we get where they want everything inspected within Azure before it reaches or makes it to the branch sites. So or even from the branch to the spokes. So traffic will get inspected on Azure Firewall and then be sent to SD-WAN sites through SD-WAN channels. All right, so I think we're good to move to the next one. So we are going to mix it up a little here. So in the earlier scenario, we were talking about, hey, you have an SD-WAN appliance and Azure Firewall. So now we have an SD-WAN appliance, still the same, but instead of Azure Firewall, it's a security NVA, or let's say a third-party security NVA. It can be any of the supported appliances here, be it Checkpoint, you could think of it, any of them, Checkpoint, Fortinet, Palo, whichever we support. So can we have this combination? So from spoke, traffic goes to the security NVA, and then SD-WAN appliance to the to the SD-WAN sites or branches connected through the tunnel. Is it supported or not? So we are not launching the polls anymore, right, Nehali? So
That's right. So good
it's
to roll
just
the answer, Cynthia.
Yes.
Okay.
Let's go ahead.
So unfortunately, this is not supported. So the only combination supported with SD-WAN and a security appliance is if it is an Azure firewall. So if you have a security NVA and SD-WAN appliance, it is not supported today. So you cannot have two different flavors of NVAs with respect to SD-WAN and security. All right, move to the next one. Okay, so we have removed SD-WAN from the picture here. So what we've done here is now you have, again, very common scenario, which we get. It's very frequently asked that, hey, we use different security providers for different services. For example, for east-west security, I am using a checkpoint, or for north-south, I need to use, or internet traffic, let's put it here, I want to use a Fortinet, Palo. So a combination of different security NVAs. What happens in that scenario? Can we use routing intent and say, for private traffic, use security NVA 1, which is Fortinet, or Palo checkpoint, and for internet traffic, use another set of security appliance. Is that supported or not?
So I'll roll the answer.
Okay. So it is supported. So you can have two different flavors of security NVA or SaaS, and they should work. But there is a caveat because you might run into scaling throughput issues, because under the hood, they are all run part of the same subnet. So you might not be able to achieve the maximum throughput that each individual appliance offers. So if this is one of your scenarios, if this is something you want to implement, make sure you engage your account teams, Microsoft account teams, and get the resources to understand what the limitations are and if it is optimal for your environment to get this working.
All
right.
right.
Okay, so now this was another scenario that we've come across. So the requirement was, so here, SD-WAN appliance that you see, I was talking about how SD-WAN appliance connects to different branch sites through SD-WAN tunnels. But here, the requirement was a little different. So think of it, this was one of our banking customers. So one of the requirements was, so Azure Firewall gives them so in the middle for security, we have Azure Firewall and then SD-WAN appliance. So Azure Firewall gives them the inspection and everything that they need. But being a banking customer, they have additional compliance and DLP requirements. So the SD-WAN appliance here, what it really has, it connects to specific partner like Netscope, which does the security at the edge with DLP and all other compliance requirements that they have. So the requirement was, hey, okay, internet traffic, go through the SD-WAN appliance. So I go in my routing intent, the ask is, for internet traffic, I pick the SD-WAN appliance. And for private traffic, I use Azure Firewall. So is that supported? Azure Firewall for east-west and SD-WAN for internet traffic using routing intent. Okay, I think we should roll the answer. So no, it is not supported. In order for, so in the previous section, we saw about two, for security NVAs is supported. But here, while for branch connectivity, you can have this combination where you have firewall and SD-WAN appliance. But when using routing intent and choosing, hey, for east-west, Azure Firewall, and for north-south or internet traffic, use an appliance, that appliance has to has to be a next-gen firewall. So you cannot add an SD-WAN appliance for internet traffic routing and inspection. That does not work that way. But with that, Cynthia, do you want to add something on this scenario?
Yeah, thank you, Shruthi. So, and thank you for the explanations. We do have one exception though, because Fortinet today is dual SD-WAN and next-gen firewall. So, in Shruthi's example, it doesn't work with any other SD-WAN only solution. But if the SD-WAN solution was Fortinet, in that case, we could have matched that requirement, because even though the next-gen firewall of the Fortinet NVAs were not enabled, it would still be recognized from the virtual hub point of view as a security NVA in addition to SD-WAN, and we could configure it as a next stop in routing intent.
Thank you, Cynthia. Do we want to roll to the next one? All right. So this was same customer, same ask, but they modified a little. Okay, I cannot pick SD-WAN appliance as my next hop for internet traffic because it is not a next-gen firewall. But can I, for my internet traffic, send everything to Azure Firewall? So Spoke sends internet traffic to Azure Firewall, and then SD-WAN advertise this, let's say a 0/0. So can Azure Firewall forward the traffic to the SD-WAN appliance and then in turn goes to Netscope for further inspection? Is that supported or not? Is that possible at all? So everything goes to firewall, from firewall to SD-WAN. The answer is no. We also have another, here we're hitting other limitation, which is Azure Firewall, for that matter, any NVA within vHub, any security, does not support force tunneling. So you cannot force the traffic from Azure Firewall to SD-WAN. That is an unsupported scenario today. That kind of chaining that we are trying to do here is not supported. So keep in mind, you cannot have SD-WAN as next hop for internet traffic. You also cannot force the traffic to Azure Firewall to SD-WAN out to internet. If you have such requirements, again, please engage your Microsoft account teams and we can work together for a solution that would meet all the requirements. That's about it. Thank you, everybody. I think that's done, Nehali.
Awesome presentation. Thanks, Shruthi.
Thank you.
So Cynthia, we are ready to any other comments before we go to the next scenario?
No, I think we can hand it over to Marc.
Okay, let's see. So our next presenter is going to be Marc. And for those of you who don't know Marc, Marc has written a fantastic micro hack on vWAN. So be sure to check it out. It does provide a lot of insights. So Marc, thank you for joining us. Over to you.
Yeah, thanks, Nehali. Yeah, so I have basically two scenarios. It's not a whole lot of questions that I have. But this is around enabling routing intent and then looking at the effects of the routes that are advertised to on-premise. And in this first question, we have a hub enabled with routing intent, and it says routing intent default because that is to contrast it from the next question. But just, this just means you click enable private traffic in routing intent in the portal. Then the question is, what prefixes do we advertise to those ExpressRoute connected branches there on the first hub? So do we advertise the complete RFC 1918 ranges, plus anything you've configured as private in routing intent or firewall manager? Or do we only narrowly advertise the prefixes that basically live in virtual WAN, right? So the spokes that you see behind the first hub and the spokes that you see behind the second, or maybe both. So yeah, but we're not running a poll here, so maybe
roll the answer.
Yeah, roll the answer. Yeah, that's better. Yeah. So what we do is we only advertise the specific prefixes that actually live in virtual WAN. So that is those spokes connected to the left-hand hub and those spokes connected to the right-hand hub, and the spoke prefix of the right-hand hub. Now, this is highlighted because note that the actual hub prefix of hub 2 that sits to the right there is not advertised out of hub 1. Normally, typically, that wasn't in the past. Before we had all these interesting things going on with third-party NVAs in those hubs, that was not so much of a problem because there was nothing really of interest for a customer to connect to in the hub directly as a destination, right? But today there is, because sometimes you have management systems for those devices that you would third-party devices that you would deploy in these hubs. And now, if you're in branch 1 and your management system for your SD-WAN devices is in branch 1, you will not be able to connect to your SD-WAN devices that sit in hub 2, right? So this is a bit of a, I think, product are working to fix this. Other things to note that are kind of interesting here is if you look at the AS paths of these prefixes, you will see that the diagram shows basically two BGP sessions, right? The top question mark is the BGP session between the ExpressRoute gateway and the MSEE, and the top bottom question mark is the actual private peering that you see on your on-premise router. So you can see that in the top session, we advertise our private AS numbers down to the MSEE router. So that's 65515 for the directly connected spokes, and then we prepend 65520 for the cross hubs prefixes. But then when they come down to you on premise over the private peering, you will see that only the MSEE public ASN number 12076 is shown. So the MSEE routers strip all private AS numbers. Mauricio, you have a question or? No. Okay. This is interesting because it means that when you go to branch 1, you see that all of these prefixes have the same AS path length. So you can no longer distinguish, the 3 and 4 spokes have the exact same prefix length as the other ones, and it will be the same on branch 2. So that creates an interesting maybe dynamic in your on-premise network. Let's go to the next one, because this one is interesting. Well, they're all interesting, very interesting. But so this ties back to something Daniele told us about global reach, where global reach is basically the tool of choice to do kind of branch to branch over ExpressRoute, right? So normally we say we don't do ExpressRoute to ExpressRoute through virtual WAN or through Azure for that matter in general. We say, no, we have global reach for that. And global reach is a nice tool because it does a short circuit between those ExpressRoute circuits, and you leverage the Microsoft backbone for all of your traffic. The only thing is you have absolutely no control over the traffic there, right? It's just all or nothing, it's on or off. Now, in the case that you do want to have some filtering, some control over that traffic between those branches, virtual WAN does provide an option there. This is not something you can turn on yourself. You have to kind of submit a support case, and then we enable this function. And this is still routing intent enabled. But now we've done that request to support. Just the question now is, what do those routes that we see on premise, what do those routes look like? Do we still see our spoke prefixes? So anything that is in virtual WAN. Do we now also see RFC 1918 prefixes maybe, or only, or do we see all of them? Well, after having thought about that for 5 seconds, can you flash the answer, Nehali?
Sure.
Yeah, okay. So there we go. So now what we do is to actually make this work, what we need to do is attract all of that on-premise traffic, or all of that traffic that you would want to send from branch 1 to branch 2. We need to attract that into Azure. But the thing that we cannot do is actually cross-advertise the prefixes that we learn in branch 2, so your actual on-premise prefixes, ingest those into virtual WAN and then advertise them out to the other express route gateway. That doesn't work. We can't do that. So what we do is we synthesize those RFC 1918 prefixes, assuming that all of your on-premise networks are privately numbered, and that attracts all of that traffic into Azure. So on both sides, we attract all of your, from branch 1, the traffic that you want to send to branch 2. We now have routes for that because these summaries are there in the are learned by the MSEE. We track that up into hub 1, then cross to the firewall and hub 2 because we have routing intent enabled, and then because branch 2 also advertises its local prefixes, obviously the more specific prefixes that live in branch 2 to that hub, out to hub 2. Now this is on the one hand, this is nice, it works, it doesn't hurt anything. The only thing is that you're now getting all of these RFC 1918 prefixes, the complete blocks advertised out of Azure, which in some cases creates problems in on-premise networks for customers. And essentially, it's not the nicest to do because essentially you could say we're kind of lying to you about what we have in Azure. We don't have those full RFC 1918 blocks in Azure, just a little bit, and then the the other branch networks that we learned. But to make this work, we have to synthesize these complete blocks and send them down. So basically, I think that was what I had to contribute, right?
Yes, excellent presentation. Thanks, Marc.
Thank you, Marc. I'm launching the poll just, so we can still have people to answer it, but at least it won't hide the screen while you share the explanations.
Yeah, okay. Okay.
And while we let people respond, Nehali, next we will have Maze presenting her scenario, so a little change of the planning, but just so you can get ready, if that's okay for you.
Sure. Right. Yeah. So May's presentation and scenarios are based on FastPath. So whenever we're ready, I can roll the question.
Yes,
welcome, Maze.
Thank you, Nehali. Yes, go ahead and pose the question. So just want to give like a quick interview of what FastPath is. It's like a feature that we enable to enhance the data path where the virtual network gateway, or let's say express route gateway, won't be in the path in order to overcome any bandwidth limitations or any other limitation with the gateway, like packet per second, flow limits. And even if you are so concerned about latency, maybe it will improve latency between on-prem and Azure. So the first question I have here, if FastPath is supported with virtual WAN.
I'll roll the answer, Maze, in the interest of time.
So yeah, the answer is yes, but with a condition where you will have to have express route direct, and the scale unit for the gateway should be 5 scale units. Every scale unit is 2 gigs. So That means when your gateway bandwidth is 10 gig, you can consider FastPath already enabled by default. Now, the 10 gig is equivalent to what we have in Hub and Spoke today, where we say FastPath is supported with the hub in Hub and Spoke topology when the gateway SQ is ultra performance, or the zone redundant SQ of ultra performance, which is ER gateway 3AZ. So yeah, it's supported with 5 scale units and Express Route Direct. Next question. Okay, now because we are focusing on security in this series here, so the next question is, if FastPath supporting when enabling routing intent, if we have Azure Firewall inside the vHub, or if we have any third-party integrated firewalls like Checkpoint, Fortinet, and Palo Alto, if that will also still support FastPath in the path.
And I'll roll the answer.
Okay, and the answer is no, not today. If you have the MVA, which is if you have Azure Firewall, or if you have one of those supported third-party firewalls inside the vHub, then FastPath won't be supported, meaning the traffic will still go through the gateway before it hits its final destination. Okay, and the last question. Okay, now what if instead of we have the firewalls inside the vHub, what if we have the MVA or the firewall in a spoke connected to the vHub? Will that still support FastPath? And the answer is no. Basically, today, FastPath supported when there is no MVA in the path, either inside the vHub or in a VNet connected to the vHub. So yeah, that's all. Back to you, Nihali and Cynthia.
Awesome. Great presentation, Maze. Thank you.
Thank you, Nihali.
So Cynthia, next up is Daniel Mauser, correct?
Yeah, we have Daniel now.
Okay.
Presenting us, I think, default route scenarios.
Okay, so yeah, welcome Daniel. For those of you who don't know, Daniel runs an amazing blog, so we'll be sharing links to that as well. And he has done quite a few scenarios on AVS. And over to you, Daniel.
Thank you, Nihali. So let me move to close the pool on my screen. So the scenario that I'm going to explain is related to kind of similar that what Marc and Daniele has explained. My customer has the need to add Azure VMware Azure solution and have this kind of transit between the on-premises. And one of the requirements is, okay, we can have a few things here that I need to explain first, right? So AVS first is a SaaS that's native. It's not an Azure native. It's a bare metal, and that's why the integration between AVS and Azure native, it's going over an express route. So when customers, they get an AVS, they get a dedicated express route circuit. And obviously, customer has its existing express route circuit, and one of the goals of the customer is to access the AVS from on-premises. So that is the most common way to access AVS. It's leveraging global reach. However, global reach is a feature that's not available in all the regions or continents. And what happens here is, if I don't have a global reach enabled, we can leverage that functionality that vWAN brings with the route intent and opening the support ticket to allow express route to express route transit. And that's the goal of this diagram. The first question is, as you see on this diagram, AVS is represented by this prefix 1057.00.21. And the question is, does on-premises in this scenario is going to receive that advertisement from AVS on that express route to express route transit using route intent? Yes or no? The answer is no. If you recall from Marc's scenario, one of the things that happens when you enable express-to-express route transit with the route intent is the advertisement of the RFC 1918, which means, in this case, the firewall inside the virtual hub is going to track the traffic from on-premises, and also is going to track the traffic from AVS. The only component that knows the 1057.00.21 is the Azure file or NVA inside the vHub when you have the ER to ER. So in that case, on-premise is not going to know directly. We don't have a direct BGP peering on that scenario, just the hairpinning over the NVA or Azure file with the route intent inside the virtual hub. We can move to the next question.
Yeah, so this is the next scenario on the default route advertisement, Daniel. And if you like, I can keep this while you are describing.
Yes.
Or I could roll the first question, either.
Yeah,
is
you
fine.
can roll the first question and I can explain the scenario. So in this scenario, we have the full route advertisement. And as you see, we do have a routing intent, the virtual hub with the routing intent. And the first question is, in the case when we enable route intent, you have two options. You can do the private traffic, which is to west, and also you can do public or internet traffic. So when you do internet traffic, what's going to happen? The NVA or file inside the virtual hub is going to start to advertise the full route 04/0. The question here is, on this specific scenario for the full route advertisement, what's going to happen towards the express route? The question is, as soon as I enable that route intent with the internet traffic, is that 00 is going to leak always to the express route, never, or it is not possible to leak down to the express route, or or I can configure or opt to enable or disable that behavior. So what is should be the answer here? Yeah, and it's configurable. So when you have the choice, obviously when you enable, you don't want to attract all the traffic. Some of the customers don't want to do that. But if they want to use the Azure file as an internet breakout for on-premises, they can do it. As you see, it's configurable. So you can enable or disable that. That is also a common scenario, just tied to the other scenario that I explained for the AVS. Most of the customers, when they use that ER to ER, they also want to do the internet breakout from the AVS. Very common for the AVS scenario. But I can, even if I have AVS in the customer on-premises, per express route circuit, I can change that behavior. So it's configurable. In this case, I can leak only for one of the circuits of the connections to the express route, which means it's configurable. Let's move to the next. So now let's talk about route advertisement when I enable the internet traffic on the virtual hub 1 with the route intent. The question here is that the full route on the vHub 1 is going to leak towards the vHub 2. And we know in the vHub 2, we do have an express route circuit connect to the vHub 2. And is that what's going to be the behavior here? Is that the full route is going to leak to vHub 2, then it's going to go all the way down to the branch 2, or always is going to do that, never, or that's configurable? What is the answer here? Never. So this is something we have covered in our documentation. By design, you cannot leak the default route between virtual hubs, which means when you enable internet traffic on the routing intent, that default route, it stays within the context of the same virtual hub. There is no way to, so this is by design. So if I need to do the same thing on the vHUB2, I need to enable the internet traffic on the vHUB2 in order to leak that the full route on the vHUB2 towards the branch 2. Let's move to the next question. All right, so now we have another route advertisement, and now we are advertising to spoke 1 and spoke 2. Again, I enable routing intent, internet traffic. I have the default route advertisement in the vHUB. And the question here is that the default route always is going to leak or never is going to leak to spoke 1 and spoke 2? Or that, or I can control that leak. That's also configurable. So if you go to the VNet connection, where you have spoke 1 and spoke 2 connect to the vHUB 1, you can control the default route advertisement.
Ready to roll the last question then.
All right. All right. Now we have kind of the same scenario. However, the advertisement goes, so the question here is, spoke 3 and spoke 4 connect to the vHUB 2. They can learn the default route from the vHUB 1. I kind of answered that on the previous or before the previous question, which you can bring the answer. And is never, because as I told you, in the same scenario for the express route, connect to the vHUB 2, by design, the full route never is not supported to leak between vHUBs. So in order to make the vHUB spoke 3 and spoke 4 to break out to the internet, you need to enable the internet traffic on the file sitting on vHUB 2. And that is what I have to cover.
Awesome. Great presentation. Thanks, Daniel.
Thank you.
Cynthia, anything else to call out before we go to Adam's scenario, right?
Yeah, exactly. Adam is next, and I've just launched the poll so we can recap on Daniel's questions. And yeah, next is Adam.
Thank you, Cynthia. Hey, everyone. Can you guys hear me okay?
Yes.
Apologies, I have getting over a cold, so I might have to clear my throat. But okay, so kind of continuing with the security questions and default route advertisement. So this particular scenario, you'll see sometimes customers will want to have an NVA and a spoke to advertise a quad 0 for inspection, or they'll want to do internet egress right through a spoke out to the internet. So in this particular scenario, would this be supported, advertising, having that traffic egress to the NVA from spoke 4 to spoke 2 out through the internet through the interhub? Would we support that particular scenario? I'll give you guys a few seconds here to think about that. I think, Nahal, you can probably roll that answer now. And this is not supported, right? I think, Nahal, showing this as being secured hubs or not? I can't remember.
Yes, so it could be either. I think that's why we haven't shown it, but we could show them.
We showed that. Yeah, and the reason, guys, too, kind of alluding to Daniel's scenario, right? Because it wouldn't be supported because the quad 0 doesn't egress cross hub, right, or inter hub, so that wouldn't be supported in that scenario, right? So you couldn't do that from spoke 4 to egress through spoke 2 out to the internet through inter hub like that, because 0 doesn't propagate across hubs, right? So that's unfortunately not a supported scenario to do that. And then I think Holly, we're probably ready for
The next question.
Next question, yeah.
Okay. This is the forced tunneling scenario.
Forced tunneling.
Yeah.
Yeah, also very common, guys. We see this a lot, right? So as you know, today, a lot of customers, particular sectors, right? Banking sectors or other sectors, they, the old term that we see is, they had inspection requirements on-prem, right? So customers advertise a quad 0 over their branch connections because they want to force that traffic to be inspected on-prem, leaving their VNets, right? So the question then becomes, can we also do that in conjunction with doing a secured hub? Because sometimes customers will want to do both, right? They'll want that spoke traffic to be inspected via the firewall, but then they'll also want that same traffic to be egressed on-prem to follow that default route. So the question then becomes, do we support that scenario where customers advertise us a quad 0 and also turn on routing intent inside the secure hub? Would we support that today? I'm gonna give you guys a few seconds to think about that one. I think Holly, we can probably roll the answer. And the question is no, right? And the reason why is that no? So technically today, when we call that out in our docs too, you can't advertise a quad 0 from branches and also do a quad 0 or do routing intent for internet breakout inside the hub, because the reason for that is that it takes over the default route table, right? And technically the 0 that gets injected via routing intent will always win via the 0 over BGP. So it's sort of pick your poison. You can do one or the other, but you can't do both today. I think that's on our long-term roadmap to support this scenario, but today in Azure it's not supported to do both in conjunction. So
yeah,
awesome.
And I'm launching the poll to recap on Adam's questions. Thank you very much, Adam.
Yeah, thank you guys, appreciate it.
Thanks, Adam. And with that, we are ready for no other than Jose Marano. So welcome, Jose. And Jose runs an amazing blog. I'm sure a lot of you already know his site, Cloud Trooper blog. And welcome, Jose. I know we went a little over, so I appreciate you standing by.
No, thanks, Nehali, for having me. And I feel a lot of pressure after speaking after such high caliber speakers. So I'll try my best here. All right.
I'm going to move you to the screen, Jose. There you go.
Yeah,
okay.
And the picture is not right.
Yes, so this is where I need to fix your scenario with this. This
exactly.
is good. Is it a good starting point for you?
Fantastic. Thank you. Right. So folks, you almost did it. Last question here, a bit of an oddball, because as you can see, the scenario changed a bit. Now there are 2 hubs, but each hub is in a different virtual one. Why would you want to do that? Different possibilities that we've seen in customers. For example, one is mergers and acquisitions, where 2 companies come together, each with their own virtual one. Another classic example of this is where you have production on one side, development on the other, but still you need some kind of interconnection for whatever reason, data replication or others. So the question is, how do I interconnect my 2 virtual ones? The first option, the first answer we have there, the first potential answer is creating a BGP-based VPN tunnel. The second option is creating, yes, a VPN tunnel, but instead of BGP using static routes, or I peer with VNet peering the two hubs together, the two virtual hubs together, or I configure private link across both hubs. So Nehali, when the drum roll ends, yeah, there you go. Okay.
There we go.
Right. So, okay. So the answer is the right answer is the second one. So why not the first one? Ideally, you might want to do BGP based. However, you are not going to be able to do that because Virtual WAN today has a non-configurable BGP autonomous system number. So when you try to configure BGP to an external entity, you will have to say, hey, my second Virtual WAN has autonomous system number 65515. And the Virtual WAN is going to tell you, sorry, that's me. That cannot be them. So that's not going to work. The third one is not right, configuring global VNet peering between the hubs, because the hubs are not in your subscription. The virtual hubs are managed by Microsoft, and there's no way to configure this kind of peering, whether global or non-global. And the fourth option doesn't make any sense. So the right one is the second one. And additionally, it's what most people want, because when you connect to virtual ones, you typically don't want to propagate everything to between both, right? You want to be very detailed in which prefixes go left or right. So static routing is normally what most customers tend to prefer for these kind of solutions.
Awesome. Thanks, Jose. Great presentation. Yep. So with that, Cynthia, I know we're going over, but we do have a bonus question. So for those of us who want to still hang out with us, we have a few more minutes with a bonus question coming from Cynthia. And Cynthia, I called her the SD-WAN queen. So these are all SD-WAN related questions. So Cynthia, if you're up for it, we can go with that.
Yeah, let me just finish launching the pool for Jose's questions so we can track on that as well. Yeah, and I also need to, yeah, perfect. Okay, so let's go ahead.
These are bonus questions.
Okay, and yeah, thanks for making it bigger. So when we decide to use SD-WAN managed appliances inside Virtual WAN, from which portal will the SD-WAN NVAs deployed inside the virtual hub be managed from? Will it be from the Azure portal, or will it be from the third-party SD-WAN portal, or can it be from both? And yeah, so the answer is like regarding the SD-WAN virtual appliances deployed inside Azure, although they are deployed on Azure VMs, they will be imported into the orchestrator of the SD-WAN partner and will be part of the overall SD-WAN overlay and appear as any other SD-WAN device from that overlay, whether it's physical or virtual. And I think we have one last question. Yeah, so when you're doing a managed SD-WAN in Virtual WAN deployment, when configuring the NVA is using the virtual hub configuration, does the configured SD-WAN NVA scale units refer to the available throughput at the SD-WAN OS level? Yes or no? So when we deploy express route gateways, in virtual WAN, we deploy them using scale units. Same for VPN side-to-side gateways, and SD-WAN for managed SD-WAN in vWAN, it's the same. We use the concept of scale units. And so the question is, do the scale unit and the associated bandwidth listed on the Azure portal when doing the deployment refer to the SD-WAN throughput? And the answer is no. Thank you, Neali. So maybe we can zoom a little bit on the two screens. Here we have an example for VMware on the left, VMware SD-WAN on the left, and Fortinet on the right. And as you can see, in the scale unit options, we have 2 to 10 or 2 to 20, depending on the SD-WAN solution. And when selecting the scale units and that come with an associated bandwidth, the bandwidth defined here is the bandwidth of the underlying VMs on which the SD-WAN OS will be loaded. So it will not be the effective SD-WAN, the effective throughput you get at the SD-WAN level, which will be subjected to like encryption and encapsulation and impact the values that are shared here on the screen. So be sure that when you do scaling of SD-WAN inside Azure, to check with your SD-WAN vendor about the equivalence between virtual appliances and the available throughput at the SD-WAN OS level. And I think that's it for the two bonus SD-WAN questions.
Awesome. Thanks, Cynthia. Any other thoughts before we close? I think we have one more poll to go, right?
We have?
Just closing the last poll.
Yes, so I've just launched the one for the bonus SD-WAN, right?
Awesome. Yep.
And I'm closing it, I think, if we have everybody answered. Yeah. Good.
Awesome. Yeah, thanks again, everyone, for joining us. I hope you all had fun. Any other closing thoughts, Cynthia, before we end the webinar?
No, just wanted to thank everyone again for following us over the past weeks and months in the series. And yeah, really enjoyed the collaboration with you, Neali, and all the partners. Thank you.
Excellent. Thank you. Thanks, everyone.